SP Smart School Digital Learning. Now we proceed to find T ratios of multiples of angle A. Angles of the type of 2A, 3A, 4A, that's so on, or multiples of angle A. Prove that sin 2A equals to twice sin of A cos of A, and second result in this is sin of 2A in terms of tan A is twice A divided by 1 plus tan square A. Well, if it is 2A here, half of this will come with sin, half of 2A is A, and half of 2A is A with cos. We shall make use of this other later on. We have sin of 2A, this can be written as sin of A plus A. So, we make use of the formula which we are already familiar, sin of A plus B, sin of the first angle cos of the second angle plus cos of the first angle sin of the second angle. Here the first angle is A, second angle is also A. So, we shall write it as sin of the first angle cos of the second angle is A plus cos of the first angle A and sin of the second angle A. If you observe, this term is same as this, so we can write down this as twice sin of A cos of A. Well, to prove the second result, we start with this sin of 2A equals to 2 sin of A cos of A. If we divide any number by 1, it remains the same. Replace this 1 in the denominator by cos square A plus sin square A. Numerator remains the same, 2 sin of A cos of A. Now, to have tan, we should have sin over cos. So, dividing numerator, I shall write it like this, and denominator by cos square A. So, this comes out to be 2 sin of A cos of A divided by cos square A. Likewise, in the denominator cos square A divided by cos square A plus sin square A upon cos square A. Now, this cos gets cancelled with this. In the numerator we have tan of A, and in the denominator this cos square gets cancelled. So, this is 1 plus tan square A. So, these two formulas are very frequently done to in different problems in mathematics and calculus. Then next we have prove that cos 2A as cos square A minus sin square A. Mark it as first. It is also equal to 2 cos square A minus 1. Mark it as second. And 1 minus 2 sin square A, mark it as third. And 1 minus tan square A over 1 plus tan square A. This is the fourth one. So, for cos 2A, we can write any one of these four formulas depending upon our need. Well, to prove this result, we again start with cos of 2A. This is cos A plus A. Now, this is the first angle and this is the second angle. Make use of the formula cos of A plus B, this formula. Use this. This is cos of the first angle, cos of the second angle minus sin of the first angle, sin of the second angle. This cos A and cos will make cos square A minus sin squared A. This is your first formula. Now, in the second formula we observe we have cos square A, not sin square. So, change this sin square A in terms of cos square A, using cos square A minus 1 minus cos square A, and this is, if when you open the bracket, this will be twice cos square A minus 1. This is your second formula. And in third formula we observe we have sin square A but not cos. So, replace cos square A by 1 minus sin square A minus 1, and when you simplify you get 1 minus 2 sin square A. So, number third. We shall read the formula like this: cos of 2A in terms of cos square A and sin square A. Second formula in terms of cos square A. Third in terms of sin square A. And fourth in terms of tan square A. Now, we are left with the fourth result to be proved. So, we continue with this. Karo? For fourth result, we have cos 2a equals to cos square a minus sin square a. This is in continuation with the result we discussed last time. So, this is the first result we have drawn divided by 1. Replace this 1 by cos square a plus sin square a, and this is cos square a minus sin square a. To obtain tan, dividing numerator and denominator by cos square a. So, we get the result as cos square a upon cos square a minus sin square a upon cos square a. In the denominator cos square a upon cos square a and plus sin square a upon cos square a. So, this cos square gets cancelled with this also gets cancelled with this. So, we are left with 1 minus tan square a upon 1 plus tan square a. Further, we have from these 4 formulas which we have just discussed, we have proved that one plus cos of 2a equal to 2 cos square a, and second result is 1 minus cos of 2a, we have 2 sin square a. If it is 1 plus cos 2a, half of this will come with cos 2 cos square a, and here also it will come with, if it is minus sign in between, it will be 2 sin square a. So, for proving these two results, we take up the result using cos 2a equals to 2 cos square a minus 1. Bring this minus 1 to the left hand side. It becomes 1 plus cos of 2a equal to 2 cos square a. Likewise, we have cos of 2a equals to 1 minus 2 sin square a, which we have already proved. Since we want 1 minus cos 2a in the second case, bring this 2 sin square a on this side and take cos of 2a on the other side, or 2 sin square a equals to 1 minus cos of 2a, or therefore 1 minus cos of, to change, interchanging both the sides, 2 sin square a. Well, these two formulas are very frequently used in calculus. Then comes prove that tan of 2a we have 2 tan of A divided by 1 minus tan square A. Before we make use of this formula, compare with this. If it is cos 2A, we have 1 plus tan square A in the denominator, and if it is tan 2A, it is 1 minus tan square A. So, tan 2A can be written as tan of A plus A. Making use of the formula tan of A plus B, this formula, using this. So, this is tan of the first angle plus tan of the second angle upon 1 minus tan of first angle into tan of second angle. Or this is finally twice tan A upon 1 minus tan square A. Well, thereafter we have 3 different formulas. Prove that sin 3A equal to 3 sin A minus 4 sin cube A. Second formula is cos of 3A equal to 4 cos cube A minus 3 cos of A. And then we have third formula in this, tan of 3A. This is 3 tan A minus 4 tan square A cube. 3 tan A minus tan cube A divided by 1. We shall prove this result 1 by 1, sin 3A to 3 sin A minus 4 sin cube A. Cos 3A equal to 4 cos cube A minus 3 cos A, and tan 3A equals to 3 tan A minus tan cube A upon 1 minus 3 tan square A. We start with first sin of 3A. This can be written as sin of 2A plus A. We are familiar with the result of sin of A plus B. Apply sin of the first angle cos of the second angle plus cos of the first angle sin of the second angle. Or this is, we know sin 2A is 2 sin of A cos of A into cos A, and formula of cos of 2A as 1 minus 2 sin square A into sin A. Further, this is 2 sin of A into cos square A plus sin A multiplied by 1 sin of A minus 2 sin cube A. We require here 4 sin cube A. So, you change this cos square A in terms of sin as 2 sin of A 1 minus sin squared A plus sin of A minus 2 sine cube A. Open the brackets. So, you will get the result as 2 sine of A minus 2 sine cube A plus sine of A minus 2 sine cube A. This is 3 sine of A minus 4 sine cube A. In the same way, we can prove the second result as cos of 3A. Cos 3A can be written as cos of 2A plus A. This is equal to cos of the first angle into cos of the second angle minus sine of the first angle sine of the second angle. We continue here. Replace this cos 2A by cos square A. So, this is 2 cos square A minus 1 minus 2 sin A cos of A. This is for sine of 2A into sine of A, or this is 2 cos squared A minus 1 minus outside is here we have cos of A. So, cos A multiplied by give you 2 cos cube A, and here this will give you cos of A minus this minus will come here, cos 2 cos of A sin square A. So, this is 2 cos cube A minus cos of A minus 2 cos of A, and instead of sin square A we shall have 1 minus cos squared A. So, this is equal to 2 cos cube A minus cos of A minus 2 cos of A plus 2 cos cube A, and finally we have 2 cos cube A, and 2 cos cube A will give you 4 cos cube A minus 3 cos of A. Next we proceed with third result is tan 3A. Tan 3A can be written as tan of 2A plus A, or this is equal to tan of the first angle plus tan of second angle upon 1 minus tan of first angle into tan of second angle. I have made use of the result tan of A plus B. For tan of 2A, we have a formula 2 tan of A upon 1 minus tan square A plus tan of A upon 1 of course. This is 1 minus, write down formula for this also, 2 tan of A upon 1 minus tan square A into tan A. and finally, if you simplify it further by taking LCM here, so this will be equal to 3 tan of A minus tan cube A upon 1 minus 3 tan square A. That is all. Next we discuss T ratios of some multiple angles. Some multiple angles, that is angles of the type of A by 2, A by 3, etc. This is proof that sine of A equal to 2 sine of A by 2 cos of A by 2. Basically, these formulas are similar to the formulas which we have done earlier, like this sine of 2A equals to 2 sine of A cos of A. Since half of this will come with sine and half of this will come with cos, and then we have sine of A equal to twice tan of A by 2 upon 1 minus tan square A by 2. It is plus here. So, it is similar to this formula, sin 2A equal to 2 tan of A over 1 plus tan square A. The difference in these formulas and in this formula is, here 2A is replaced by A and on the right hand side A is replaced by A by 2. For proving this result, we proceed in the same way as sine of A can be written as sine of A by 2 plus A by 2. If you remember, we did the same in case of sine of 2A. Apply the formula sin A plus B, sine of first angle cos of second angle plus cos of first angle sine of second angle, or this is further equals to 2 sine of A by 2 cos of A by 2. So, you get the first result. Further, for proving second result, we have sine of A equal to twice sine of A by 2 cos of A by 2, and if you divide it by 1, it does not matter. So, this is 2 sine of A by 2 cos of A by 2 divided by cos square A by 2 plus sin square A by 2. So, to obtain tan here, dividing numerator and denominator by cos square a by 2. So, we have 2 sine of a by 2 cos of a by 2 divided by cos square a by 2. Cos square a by 2 divided by cos square a by 2 plus sin square a by 2 divided by cos square a by 2. This cancels 1 1, this square cancels with this. So, you are left with 2 tan of a by 2 upon 1 plus tan square a by 2. Further, prove that cos of A equal to cos square A by 2 minus sin square A by 2. This is first formula. 2 cos square A by 2 minus 1, this is second formula. In terms of sin square A by 2, we have 1 minus 2 sin square A by 2, this is third. And finally, we have 1 minus tan square A by 2 upon 1 plus tan square A by 2. This is number 4. I leave the proof of this result, but we can compare the result with this. Cos 2A is cos square A minus sin square A. If it is 2A, half of this will come with cos square A and half of this will come with sin square. Similarly, in this case, half of A is A by 2, cos square A by 2, and half of this will come with sin. The only difference is here 2A is replaced by A, and on the right hand side A is replaced by A by 2. Then we have 2 cos square A minus 1. Here we have A by 2. This is equal to 1 minus 2 sin square A. Here we have 2 sin square A by 2. And finally, 1 minus tan square A upon 1 plus tan square A. Then here we have a similar formula. We have 1 plus cos of 2A. Prove that. We have already proved 2 cos square A. Here we have proved that 1 plus cos of A is 2 cos square A by 2, and 1 minus cos of A is 2 sin square A by 2. The similar result is 1 minus cos of 2A is 2 sin square A. Well, here prove that tan of A equal to 2 tan of A by 2 upon 1 plus, no, it is minus 1 minus tan square A by 2. Well, similar to the formula is 2 tan 2A, which we have already proved, 2 tan of A upon 1 minus tan square A. So, while using the formula, you can compare these formulas, and in trigonometry what is required is the comparison of the formulas. We now discuss some of the problems which are based on the concepts which we have done. The first problem in this is find all the 5 T ratios from cos x equal to minus 1 by 2 when x lies in third quadrant. And in third quadrant the value of cos x is negative here, minus 1 by 2. Well, when we say x lies in the third quadrant, the figure will be like this. Starting from O plus x, we have angle which lies in the third quadrant. The magnitude of the angle in the third quadrant will be between 180 degree and 270 degree. We have done this result that all sine, tan and cos. This we have discussed, all sine, tan, cos. Cos x is negative here. So, in the third quadrant, secant x will be negative, sin x is negative, cosec x is negative, but tan x and cot x are positive. So, there are two approaches for this. First approach is we can make use of the formula that 1 plus, using the formula 1 plus tan square x equal to secant square x. Now, if cos is minus 1 by 2, so from here we have secant x equal to minus 2. Or we have tan square x equal to secant square x minus 1 by transposing 1 to the right side. This formula is we have done in class 10th. Or tan square x equal to minus 2 square minus 1, and if you simplify this, it comes out to be 3. Minus 2 square plus 4 minus 1, 3. So, therefore, tan of x equal to plus minus root 3. Since x lies in third quadrant and tan x is positive in third quadrant. So, therefore, taking tan t small, tan x equals to plus root 3. Therefore, cot x is 1 by root 3. Both are positive in the third quadrant. Then next is 4 trigonometric ratios we have in hand. Number 1 cos x, secant x, tan x, cot x. Next we want to find out sin and cos, sin and cosec. Now using sin square x plus cos square x equal to 1. So, sin square x equal to 1 minus cos square x, or sin square x is 1 minus 1 by 2 and square of this, because it is given cos x equal to minus 1 by 2, or sin square x 1 minus 1 by 4, that comes out to be 3 by 4. So, therefore, sin x is 3 by 4 square root of this with plus minus sign equal to plus minus root 3 by 2. Now, taking sin x equal to minus under root 3 by 2. Why? This is x lies in third quadrant. This is because x lies in third quadrant. Therefore, cosec of x is minus 2 by root 3. So, we can put down the values like this. Sin x equal to minus root 3 by 2, cos x minus 1 by 2, this is given, tan x equal to root 3, and cot of x 1 by root 3, reciprocal of tan, secant x minus 2, reciprocal of cos x, and finally cosec x equal to minus 2 upon root 3. This is one approach. By using the formula 1 plus tan square x equal to secant square x, when cos x is given, we obtained secant x, substituted its value here, we obtained tan. Tan is positive in the third quadrant. So, we have tan this, reciprocal of tan x is cot x, which is 1 by root 3, and then we find sin x and cosec x by using this formula. Now, another approach is if you consider this right angle triangle given second way, given cos x minus 1 by 2, and if you consider this figure OMP right triangle, so OM base over hypotenuse OP is minus 1 by 2. So, here in this case length is OM, this is 1 unit and OM is 1, OP is 2 units. I am taking here instead of this minus 1, I am taking plus 1 only, because length of the side of triangle is always positive, its magnitude. Even if you write it a minus 1, so this will indicate this lies along O x dash. This side is 2 units and you need to find out PM. PM is OP square minus OM square under root with plus minus sign. So, this will be plus minus 4 minus 1 under root plus minus root 3. So, therefore, length of PM is root 3 and this is minus root 3. Mind it, learn this, the minus indication is whether it is parallel to OY dash or O plus Y. So, now you can find out the other trigonometric ratios by using the sides of this right angle triangle. For example, we have sine x with perpendicular upon hypotenuse. Cos x is given, cosec x will be minus 2 by root reciprocal of this, and etc. You can find out. Next we have, I give an exercise, next is find given cot x to minus 5 by 12, x lies in second quadrant. So, we find other 5 T ratios. So, first method is using the formula. Using 1 plus cot square A equal to cosec square x. If angle is A, write down A, x is x. So, this is 1 plus minus 5 by 12 square equal to cosec square x. So, this is equal to 13 by 12 square, simplify the cosec square x, or you can write on this as 169 upon 144 cosec square x. Therefore, cosec of x equal to plus minus 13 by 12, taking the square root. taking cosec x equal to plus 13 by 12. Why? Reason being x lies in second quadrant, and in second quadrant we know that sine and cosec have positive value. So, from here we have sin x equal to the reciprocal of cosec 1 by cosec x. So, this is 1 over 13 by 12, ultimately 12 by 13. For cos x, use cos x equal to 1 minus sin square x and substitute the value here. 1 minus 144 over 169, which is 5 by 13. Now, taking cos x to minus 5 by 13. Why? Because in second quadrant cos x is negative. So, secant x is minus 13 by 5, reciprocal of cos x. Now, tan x equal to minus 12 by 5. Why? It is again reciprocal of that cot x. If you want to make use of the triangle, then this is y axis, x axis, the angle in the second quadrant is like this. Second way, given cot x equal to minus 5 by 12, base OM upon PM 5 by 12. So, this is minus 5, this is 12. I have taken 12 as positive because it is parallel to O plus y. I have taken this negative because it lies on the along OX dash. But length is 5 units. Length is a magnitude which is always to be taken as positive. So, now you can make use of this sin of x. This is PM upon OP, but before we proceed this, we find out OP from this result. OP by Pythagoras theorem, this is PM square plus OM square under the root, and this revolving line OP is always to be taken positive. OP equals to 25 plus 144 or OP equals to plus 13. So, this is equal to 12 by 13. Cos x is OM upon OP. This is minus 5 by 13. Secant x OP over OM minus 13 by 5. Then tan x equals to PM upon OM minus 12 by 5, etc.